Hey everybody, we're back. I think this will be the final day without me, either in person or I'll be at least present on a Zoom to teach virtually. I appreciate you guys working hard while I'm out. We're still learning a lot, and I'm proud of you guys. I'm getting good messages from you all who are trying to stay on top of things, and you're asking good questions, so keep it up. Keep as my buddies and I say, keep chopping wood, carrying water. Next thing you know, you'll have a nice little house built. You just gotta, day by day, chop that wood, carry that water. Even when it feels like a grind. Even when you have COVID. No, you should be resting if you have COVID. I'm just gonna do like 3 problems. This is gonna be a shorter video than yesterday, because this is just a chance for you to practice again some of these higher level concepts. I'm hoping that yesterday, maybe 2 or 3 things clicked. I'm hoping today maybe 2 or 3 things click. Just keep leaning in and keep practicing, because there are a lot of patterns to be found here, a lot of words that you've recognized before that hopefully can sink in on a newer level. And so let me try a few. I'm gonna do I think I'm gonna do number 1, just because we haven't done like a traditional graphing equation in a while. And then I think I'm gonna do number 10, these true or false, and show you how the trick to doing number 10 is by knowing which one of these each of them are. And then notice, look, there's another hard problem like this, and there's some true or false there, and then there's another one of these domain and ranges, so we'll be able to get after it. So let's pretend like it's number 1 on the test, and you see this problem. What do? Well, we look at the a value, it's -1. I see that this b value is inside the parentheses. So when I see that, I know that I need to factor that 2 out, which then divides the c value by whatever you factor out. So this is my new equation. So the amplitude is -1, the b value is 2, so I off to the side do a quick 2 pi divided by the b value, so I get my new period, which is pi. It's plus pi over 2, so that's moving it left 1 tick mark, then plus 1, so up 1. So I take a color and I just graph a negative cosine graph that completes its cycle in pi units. So just to help me with that, I'm going to draw my boundary at pi units, and I'm going to draw a negative cosine, so I know that it makes that V shape. And notice where I put my middle points. It's a perfect balance. Okay, and so then I'm going to move each of those left 1 space and up 1 space, which is the easy part. So let me slow down again and say that, like, you find all of this, and this is where students either freeze or they get it. You've got to know what just a regular cosine looks like, so that then when you see a cosine with -1, then you also know what it looks like. I'm going to shut the door real quick. Okay, so I knew that a negative cosine, I knew that cosine normally starts at 1, so a -1 would start down here, and then it would look like that. Shifted left and up, so then I can switch colors if I want, and then just go left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Oops, that should be actually here. Left 1, up 1. So there it is. I'm fine with you leaving some of that, or you can go back and erase some of your extra stuff. Probably want to show that they both turn. It's the lowest, that's the highest, lowest, something like that. All right. Notice I have 5 clear points. Every time you graph, you need to have 5 clear points that represent your period. All right. Domain and range. We talked about what the domain is every time. The range, remember, it's lowest value that the graph touches to highest value. And the way you do that is you look at the amplitude and the vertical shift. What is this? I always go straight to the sine wave, so I would graph this like it was this. 1, 2, 3, 4, 5. So that's a sine wave. So what's the A? What's the B? What's the C? What's the D? True or false? Let's do this. True or false? The period of a secant graph and a cosecant graph is 2 pi. First, we got to know what that means. That means, does a secant graph complete its cycle in 2 pi units? Well, let's go look at these secant graphs again. Which one's which? Tangent is the one that's always going up. That's this one. And cotangent is the one that's always going down. That's this one. So notice tangent repeats itself. It starts here and finishes there, and then it repeats. So that's pi units. That's pi. So tangent and cotangent, they actually have a period of pi. It only takes 2 tick marks for a tangent graph and a cotangent graph to complete their cycle. So tangent actually has a period of pi. So does cotangent. We'll write that down below it. But these two, secant and cosecant, which one's which? Which one's which? The way I remember it is that secant is the one that gets split down the middle. So this is a secant graph, and this makes this a cosecant graph. So how long are their periods? Well, looks like it starts here, and the question is, does it end here? Or does it end here? The answer to that matters. It actually ends here. Here's why. Because the period has to do the complete cycle that then you just repeat. And a secant of x, you have to have one that's up here, a parabola that's up here, and then a parabola that's down here. And then it repeats up here, down here, and then it would repeat up here, down here. So it actually does take a period of 1, 2, 3, 4. It has a period of 2 pi. So secant and cosecant do have a period of 2 pi. It takes 4 tick marks for them to complete a cycle. And let me show you this. This is 60 seconds, but like it literally is such a huge connection. Do you remember how we talked about last unit that the reciprocal of sine is cosecant? You remember how those are reciprocals? So basically what I'm saying is that cosecant is 1 over sine. Like if you flip sine, you get cosecant and vice versa. Well, check this out. Here's y equals sine of x. And here's y equals cosecant of x. That's pretty nutty, right? Let me explain why this happens. Notice they share a point there, 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 there. So the peaks, they all share points at the peaks. Why do you think they do that? Well, look at the y value. The y value is 1. What is the reciprocal of 1? It's just 1. So this is the only point where they match the same. What about this point right here? The sine wave, the blue one, has a value of 0. What's the reciprocal of 0? It's undefined, which is why the green graph has an asymptote there. It has a blank. It skips over it. Okay, so when you're graphing cosecant, if you can graph a sine wave, then you know that it's going to touch the top of the maxes and mins, and it's going to have an asymptote at the zeros. So like if I were to graph a cosecant, if I told you to graph this by hand, then I would do this. This is how I would graph that by hand. I would graph a sine wave. I'm just like estimating, but you get the idea. And then I would know that there's going to be asymptotes here, everywhere there's a 0. And then I'm going to have this, and I'm going to have this, and I'm going to have this, and I'm going to have this. And I know that I would then erase the blue, but I officially graphed a cosecant graph, and I use the sine wave to help me do it. It's kind of gnarly. So when you're looking at this assignment here, it's one way to know, okay, there's a cosecant goes with sine like that. But notice how secant goes with cosine. But anyways, once you know these four, you do those first. So now you can answer this question. We already said that that's true. Part B, the graphs of secant and cotangent have asymptotes at every whole pi unit. So let's start with cotangent. It has an asymptote here. That's at pi. So that one checks out. What'd they say? Cotangent checks out. What about secant? Secant is over here. Where's this asymptote right there? That's it. That's it. Pi over 2. So that one doesn't check out. So that's false. See how you can use, once you fill in the right names and you know which one's which, you can use those to help answer your questions. The period of sine and cosine is pi. Heck no. Whoops, I just said heck no and wrote a T. Yeah, we know the period of sine and cosine. The period of sine and cosine is 2 pi. The graph of secant is always increasing. I go to secant, it's down here again. Is this graph always going up? No, it's clearly going down right here and right here. It's going up right there and right here, but it has some parts where it's going down, so that's false. So work through these, try these true false, try all of these problems, and when I'm hopefully going to be back tomorrow to help you guys out. Looking forward to a reunion. Good luck on this, help each other, and your assignment is just to finish as much of this as you can. Love you guys. See you soon.